Hello and welcome back to the Code Athlete. Today we're going to look at Kickstart Round F 2021, Problem A, the trash bins. It's the simplest of the 4 problems that were featured in the Round F, and 60% solved it from all participants, so I think we will be fairly fast with this one. In the city where you live, Kickstart Land, there's one particularly long street with n houses on it. This street has length n and the n houses are evenly placed along it. That is, the first house is at position 1, the second is at position 2, and so on. The distance between any pair of houses I and j is I minus j, where x denotes the absolute value of x. Yes. Some of these houses have trash bins in front of them. That means that the owners of such houses do not have to walk when they want to take their trash out. However, for the owners of houses that do not have trash bins in front of them, they have to walk towards some houses that has a trash bin in front of it, either to the left or the right of their own house. To save time, every house owner always takes their trash out to the trash bin that is closest to their house. If there are 2 trash bins that are both the closest to a house, then the house owner can walk to any of them. Given the number of houses and the description of which of these houses have trash bins in front of them, find out what is the sum of the distances that each house owner has to walk to take the trashes out. You can assume that at least one house has a trash bin in front of it. Easy enough, t test cases, n is the integer given, second line of length n, representing which houses have trash bins in front of them. Then it has a 1 in it, the string. Otherwise, it's a 0. Easy enough. That we have a string of length n means n can't be too large. Anyways, yes, so here 5 times 10 to the power of 5. First example, every house has a trash bin. No one has to walk. Second case. This owner has to walk 1 to the left, this one has to walk 1 to the right, this one has to walk 1 to the left, and this one has to walk 2 to the left. So total 1 plus 1 plus 1 plus 2 is 5 unit distances that need walking. I would say this is simple, because we can do the following. I will take the example of the 6 here. So we have 1, 0, 0, 1, 0, 0. That was the given trash bin. So we have here a trash bin here. We will pass this in a forward manner and create the following numbers. The first one, because it has a 1, we try to create an array where we write in the distances that person has to walk. So for the first entry, because it has a trash bin, we start with a 0. And now we look at we write the distances that this person has to walk to the left to get to the nearest trash bin. So this person, because we know the previous one had to walk 0 to the left, this person has to walk 1 to the left. This person has to walk 2 to the left because it has to walk 1 more than the person left of it, which has to walk 1. This person now would need to walk 3 to the left because it's 1 more than the 2. But because it has a trash bin on its own, it actually can stay here. And from here it starts again with 1, 2. And now we can do the same coming from the right side, parsing it in the opposite direction. And asking how much does it have to walk to the right. And this one has no trash bin to the right, so we write infinity or a very large number in our code later. This one also infinity. This one has a trash bin, so it's 0. This one then adds 1 because it doesn't have a trash bin. This adds 1. This has a trash bin on its own, and we take the minimum of these 2. So this is 0, this is 1, 1, 0, 1, 2. Sum is 5, and that's our solution. And we can immediately start implementing this. So we read the input. There's one number n and one string s. The result we are looking for is just a number. We initialize it with 0. And yes, we have. Can we store actually that many numbers? Yeah, 10 to the power of 5 is not that much. Walk left, walk right. We have an infinite constant defined, which is the largest integer number, so that should be fine to use here as an infinity escape. There should be no edge cases because there is at least one trash bin here, so that should be fine, I would say. And yeah, now we iterate. The current value we have to walk to the left. We will track this and we set it to infinity. And now it's simple enough. Walk left. The new person has to walk one more than the last one. So it's actually, let us take inf half, because then we don't have any overflow issues. But this is only the case if this person doesn't have trash bin. In the else case, this person has a trash bin and walk left is 0. Yes. And now the current value is the one we just pushed back. This is a shortcut again. And now we do the same, but iterating from right to left. J is now the variable going from right to left. So it's basically symmetry. And now we just iterate through these two and always sum the minimum to the result. We again need our J because walk right was now constructed in the opposite direction as walk left. So the first entry of walk left corresponds actually to the last entry of walk right. So result gets added to the amount of the minimum of walk left E or walk right of J. And that should be it. Let's test it. Oh, I actually haven't specified any samples. I have to download them first. You don't need to check any additional test cases. Yep, no differences shown, so this is correct. Waiting for the judgment. Taking some time, taking some time. Yes, so correct, easy problem. I hope you liked this short one. Feel free to comment if you had any difficulties. Otherwise, the code will be again pushed to my GitHub repo, again with my notes. Not really that much in this problem. You will find the link below. As always, I would be happy about if you leave a like, subscription even, or just ring the bell to watch my future videos. See you in the next one. Bye!